Okay, we're going to use the dot product here. We have three vectors, vector u, vector v, vector w. We are going to find u dot v, and then we're going to take that result times the vector w. Well, u dot v is a dot product, which is going to result in a scalar. W is a vector. When I take a scalar and I multiply it through to a vector, the result will be a vector. So that's one of the first things I do is I kind of look at what they're asking me to do and what my result should look like. My result should look like a vector. So I'm going to find u dot v first. So I've got u is negative 1, 3. That's in component form. V is 2, negative 4. We're going to find u dot v. U dot v is negative 2 plus negative 12, which is negative 14. So this scalar right here is negative 14. I'm going to take that negative 14 and I'm going to multiply it through to the vector w, which is 1, negative 2. So here's w right here. There's the vector w. And here's the negative 14. And when I multiply that through, I get negative 14, comma, 28 in component form with pointed parentheses. And that's our example. Okay, you go ahead and try the one on the right and try and work through what you think your result is going to be. Press pause, and when you come back, I'm going to explain it. Okay, if you got negative 28, you are correct. And this is what I did to work through that. U is a vector. 2v is a vector. The dot product of two vectors will result in a scalar. So u is negative 1, 3. 2v is 4, negative 8. Simply taking vector v and multiplying both components by 2. And the dot product is negative 4. We lost our pen here. And the dot product is negative 4 plus negative 24, which is where we get negative 28 from. Okay, now that we've gotten some practice with the dot product, trying to say practice and dot product at the same time, it doesn't work. Now that we've gotten some practice with the dot product, we're going to now incorporate that magnitude in. Remember what magnitude is. So the dot product of u with itself is 5. What is the magnitude of u? Okay, this right here, you're probably going, I don't know. I have no idea. That's because we need to go back to our notes. The dot product of u with itself is 5. So we're going to go back to our notes. The dot product of a vector with itself is equal to, well, that's number 4 right there. So the dot product with the vector in itself is equal to the magnitude squared. This is an example where if you're taking notes and you don't utilize your notes, you're making a mistake because you're not really able to utilize them anymore to learn from them. So you're kind of treating yourself as having this photographic memory or being a sponge that can absorb everything and understand it the first time you hear it. That is a very, very rare ability, and even at some point, people have to go back and look at their notes because it is so much information to contain in your brain. So the dot product of u with itself looks like that. And then from that property number 4, it said that that's equal to the magnitude squared. Well, if the dot product of u with itself is 5, I can put a 5 in there. And then that's equal to the magnitude squared. And if I want to find the magnitude, I square root both sides. and magnitude is always positive. So the magnitude of u is equal to the square root of 5. So this is a great example, great example of utilizing your notes. You can't just take them and then not ever rely on them. You need to actually go back through and refer to them. Okay, where do we do this? Where do we use this? The angle between two vectors. So if theta is the angle between two non-zero vectors, so I have a vector, and then I have maybe another vector going that way. I can take this vector right here and I can move it anywhere because location doesn't define a vector. It's all about direction, which it continues to have the same direction no matter where I put it, and magnitude. Magnitude is its size. So there we go. So we've got, I'm going to just put them so that they have the same initial point. And now I'm going to say, okay, well, we want to find the angle between these two vectors. Whether this vector is here, 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 or here, the angle between the two vectors is the same. It's easiest for us to visualize in our learning having the same end point or the same beginning initial point, not the end point, because those are the end points. For them to have the same initial points, just so that we can visualize that angle that's between the two vectors. If we want to find this angle theta, we can use this formula right here. The cosine of theta is equal to u dot v divided by the product of the magnitudes of the two vectors. Now remember that the cosine of theta is equal to a ratio. And this ratio has to be between -1 and +1. It could actually equal -1 or +1, but it can't be anywhere outside of that inequality. So in order to find theta, we're going to be putting that ratio in so that we can get our angle theta. So let's take a look at an example. We're going to find the angle between these two vectors. I like to draw the vectors. So if I'm going to draw vector u, I'm going to go right 1, 2, 3, 4 units, and then up 1, 2, 3. So there's vector u. And vector v, I'm going to take this point and I'm going to go right 1, 2, 3, and then up 1, 2, 3, 4, 5. And that's vector v. So I'm going to move this here. I want to find the angle between those two vectors. I should actually move v over here. And now look at that. Oh, very nice. So it's going to be a pretty small angle. It's going to be a pretty small angle. It's this angle right here, theta. So let's use our formula. The cosine of theta is equal to the dot product of the two vectors divided by the product of their magnitudes. Divided by the product of their magnitudes. So the cosine of theta is equal to u dot v, that would be 12 plus 15, 12 plus 15, over the magnitude of u would be the square root of 16 plus 9, which is 25, and the magnitude of v would be 9 plus 25, which is 34. So I'm going to have 27 over 5 times the square root of 34. I'm not going to simplify it any more than that because I don't want to make a mistake in my addition, in my division, in breaking down radicals. I don't even want to go there. So I'm going to be putting this into my calculator anyway the inverse cosine of this ratio is going to equal my angle theta. So we go over to our calculator, we put that in. Make sure you're in degree mode. We want to get this in degrees, and theta is approximately. Go ahead and put that into your calculator. And if you're ready, I'm going to say the answer, 22.166 degrees. So that's the angle. This is the angle between the two vectors. So whenever we're finding the angle between the two vectors, we're going to find the smaller angle, not the larger angle. So it's never going to be the major angle. It's going to be the minor angle. Kind of from geometry, the major arc, the minor arc. Now, what if I ask you, what is the cosine of theta? What is the cosine of theta? What is the cosine of theta? What is the cosine? Oh, that's not a highlighter. The cosine of theta. So I'm kind of just playing around here while you think about this. What is the cosine of theta? The cosine of theta, let me look at my work. The cosine of theta, well, the cosine of theta is u dot v divided by the product of the magnitudes, which was equal to the cosine of theta. Well, the cosine of theta is, here I am, look at what I'm doing here. I'm going to play a little karaoke right here. Here's my little karaoke ball. Well, the cosine of theta is this fraction, u dot v divided by the product of the magnitudes. Well, the cosine of theta in this particular problem is 27 over 5 times the square root of 34. So over here, what's the cosine of theta? The cosine of theta is the ratio. So the cosine of theta is the ratio. Make yourself a note. The cosine of theta is the ratio. In this particular case, it's 27 over 5 times the square root of 34. But generally, it is u dot v divided by the product of the magnitudes of the vectors. And I think that this, if you put this into your calculator, you should get about 0.926. That's always a great question to ask. Always a good question for me to ask on a test. Okay, let's go ahead and do this try. Go ahead and press pause, because when you come back, I am simply giving you the answer. So press pause now, because here comes the answer. Theta is approximately 53.130 degrees. If you got that, you're all aces. You're all aces. When we come back in the next video, we're going to finish it up talking about vectors being orthogonal, vectors being parallel, and determining whether or not you've got orthogonal, parallel, or vectors that don't fit into either one of those categories.